Cryonics is a controversial and often misunderstood field of research that aims to preserve human bodies or brains at very low temperatures in the hopes that they can be revived and cured of any ailments at a later time. This process involves cooling the body or brain to a temperature of around -196 degrees Celsius, which is the temperature of liquid nitrogen. The idea behind cryonics is that by preserving the body or brain at such a low temperature, the decay and damage that would normally occur after death can be slowed down or even halted. The hope is that in the future, when medical technology has advanced sufficiently, the body or brain can be revived and any medical conditions can be cured. One of the major challenges in cryonics is the preservation process itself. To prevent damage during the freezing process, the body or brain must be treated with chemicals that prevent ice crystals from forming and damaging the tissues. Once the body or brain has been frozen, it is then stored in liquid nitrogen, often in a specially designed cryogenic chamber. Another challenge in cryonics is the scientific feasibility of the process. While some experiments have been conducted on the cryopreservation of cells and tissues, the scientific community remains divided on the feasibility of cryonics for entire human bodies or brains. Some experts argue that the freezing process itself causes significant damage to the tissues and cells, making reanimation unlikely. There are also ethical and legal challenges associated with cryonics. Some people argue that it is unethical to freeze a body or brain in the hopes of future reanimation, as it may be a form of false hope or exploitation of vulnerable individuals. Additionally, there are currently no legal frameworks in place to regulate cryonics, which raises questions about the rights and responsibilities of individuals who choose to undergo this process. In conclusion, cryonics is a controversial and largely unproven field of research that aims to preserve human bodies or brains at very low temperatures in the hopes of future reanimation. While the concept of cryonics may be appealing to some, there are significant challenges and limitations associated with this process. As research in this field continues, it will be important to address the scientific, ethical, and legal considerations associated with cryonics and to approach this field